Hi, and welcome to the Unit 1.2 Characteristics of Atoms note video. So again, for those of you who have your notebook, you want to start with your table of contents. You're going to write the title down, 1.2 Characteristics of Atoms. And for me, I'm starting on, my notes will start on page 11, so whatever page your note starts on, please write that down there. Okay, so let's go ahead and find our note page, Characteristics of Atoms. All right. So at the top, always, we're going to write the title, 1.2 Characteristics of Atoms. Don't forget the page number. And then we're going to write the objective. So the objective here is to describe 3 properties that characterize the atom and calculate the property using subatomic particles. So I just want to pause for a moment. In the previous lesson, we learned about the subatomic particles and their charges, etc. And the reason why we learned that first is so that we can then use that information to describe characteristics of atoms. So if you need to pause to get the objective down, go ahead and do so. Now, why do we need the characteristics of atoms? So here's the importance. There are 118 types of atoms as seen on periodic table. So here's a periodic table, and I'm not even sure if I can capture the whole thing in the shot, but there are 118 elements that are known. And when I say elements sort of describes 2 things. You can use it to describe a type of atom, or you can use it to describe a substance made of only one type of atom. Okay, so you can think of all of these elements. For each of these elements, there's an atom that represents that element. So as you can see, there are 118 types, and each element can have different masses. So for example, hydrogen can have a mass of 1, it can have a mass of 2, it can have a mass of 3. Those are known as isotopes or charges. Excuse me, those are known as ions. And so we needed a way to distinguish these, correct that spelling error there, these atoms, okay? So if you need a chance to write down the importance, go ahead and do so now. Pause the video. Okay, so as I was saying, we need a way to distinguish these atoms, and the way that we do that is we use 3 characteristics to help us distinguish and describe the atoms. So we'll write that information down. And here's the table. I'll actually zoom this in a bit if I can. Okay, so you're going to make a table with 3 columns and 4 rows, all right? And I'll just say that the middle row and the last row need more room. The last row needs the most, so make sure you have enough room to write it. So in the first column, you're going to write the property, and in parentheses, you're going to write the symbol. So as I said, there are 3 properties there: atomic number, mass number, and charge. Let's go ahead and number those. So these are the 3 key properties, 1, 2, 3. Now the atomic number has a symbol of Z, mass number has a symbol of A, and charge has a symbol of capital Q. These are all capital letters. All right, in the second column, you're going to write the description. So what's the description of the atomic number? This identifies the atom. And I'm going to tell you what I mean by that. So when I say identifies the atom, I mean that, for example, if you look on the periodic table, the atomic number of sodium is 11. So all sodium atoms and only sodium atoms have an atomic number of 11. Okay, so that says all sodium atoms and only sodium atoms have atomic number of 11. All right. For the mass number, this describes the mass of the atom, and this is important for something called isotopes, which we'll be looking at later. But that's what the mass number describes, just how heavy the atom is. And the charge tells you if an atom is positively charged, that's called a cation. If it's negatively charged, called an anion, or if it's neutral. So those are the three options. So some atoms are have a positive charge, some have a negative charge, and some are neutral. The ones that are charged are what's called ions, by the way. So if an atom or anything has a charge, it's called an ion. Okay. So after you write down the description, the last thing you're going to do is describe how to calculate it. So for the atomic number, it's easy. It's just the number of protons. So this is where the subatomic particles come in, right? So if you know the number of protons an atom has, you know its atomic number. And the other cool thing is if you know the atomic number, you can identify it on the periodic table. So for example, if I told you something had 23 protons, you would look on the periodic table, find 23, and you're like, oh, that element must be vanadium, because it has an atomic number of 23, or 23 protons. So that's the atomic number, it's the number of protons. The mass number, which describes the mass, right, is equal to the number of protons plus neutrons. Now, I think you saw in that video that the reason for that is that only protons and neutrons have a significant mass. They have a mass number of about 1 AMU. Electrons don't weigh much, so they don't contribute much to the overall mass of the atom. So when you want to calculate the mass of the atom, you just need to tally up the number of protons and neutrons, since each of these have a mass of 1 AMU, and ignore the electrons. On the other hand, for the charge, which is our last one here, the charge would only involve subatomic particles that have charges. And the only two that have charges are protons and electrons. Protons have a positive charge, electrons have a negative charge. And the cool thing is that positive and protons begin with a P, so it's easy to remember. Now, the way that you can calculate it is you can actually calculate the charge by doing the number of protons minus the number of electrons. That will give you the charge. But a lot of people actually like using mental math instead of using this calculation. It's just sort of reasoning it out. So if you have an atom that has more protons than electrons, then the charge will be positive. And that should make sense because protons have a positive charge. So if you have more of them, the positive and negative charges will cancel out, and then you'll have some leftover protons. On the other hand, if you have more electrons than protons, the positive and negative charges will cancel out, and you would have some leftover electrons, and that will give you an overall negative charge. And finally, if you have the same number of protons and electrons, it of course will be neutral since they'll cancel each other out. So if we look at, for example, the Bohr model that we drew on the previous page, here we have 1, 2, 3, 4 protons and 1, 2, 3, 4 electrons. It's the same number of protons and electrons, so it will have a neutral charge, zero charge. But if we removed one of the electrons, then we would have 4 protons still and 3 electrons. So in this case, the overall charge would be positive 1. Why? We have more protons than electrons, so 3 of the protons and electrons will cancel each other out, and we'll have 1 more proton left over, giving us a +1 charge. Okay, so if you need more time to copy this table down, make sure you pause the video. And now I'm going to go into some examples. Okay. So let's look at this first one together. First, take a moment to copy down the information, and then we will do this example together. Okay, so for this example, it's asking us to calculate the mass number, and the symbol is A, capital A for that, for the atom described above. The atom described above, it says number of P is equal to 14, so the number of protons, you have 14 protons. Number of N, or number of neutrons, is 13, so you have 13 neutrons, and number of electrons is equal to 16, so you have 16 electrons. All right, so for the mass number, the key thing to remember is that the mass number only involves the subatomic particles with mass, with a significant mass, so that will be the protons and the neutrons. So we're going to just focus on those two numbers. And remember that the mass number is equal to number of P plus number of N, right? So that's so simple, right? Remember, we're gonna ignore the electrons. So because they have little mass compared to the others. Okay, so to get the mass number of protons plus neutrons, we have 14 protons and we've got 13 neutrons. That gives us a mass number of 27. So it's that simple. The next part is asking us to calculate the charge. So if we're calculating the charge, we only want to focus on subatomic particles that have charges. So protons have charge, neutrons do not, so we ignore those here, and electrons have a charge. So we're just going to focus on those two. And so we can do it one of two ways. We can either use the equation charge is equal to the number of protons minus the number of electrons, in which case we have, I'm just put it right on the side here, we have 14 protons and 16 electrons, so 14 minus 16, which will give us a -2 charge, right? We can do it that way. Or we can do it using some mental math. So what I do here is I write down my number of protons. I would write down 14 protons, and then next to I write down the number of electrons, 16 electrons. I compare which ones I have more of. So I have 14 protons, 16 electrons. So I have more electrons. That means that my charge is going to be negative, right? Because I have more electrons than protons. So the charge is going to be negative because we have more electrons than protons. And it's going to be -2 because I have 2 more electrons than protons, right? So 14 of the electrons will cancel out with the 14 of the protons, giving me 2 left over. So the charge will be -2 because we have 2 more electrons than protons, okay? So that's doing it mentally. So for those of you who like calculations and you feel comfortable manipulating it, just use the calculation if that's helpful, or I know a lot of people like mental math for this. All right, the last part is asking us to identify the atom. Now to identify the atom, notice I have the symbol here for the atomic number is Z. The reason why that's important is because the atomic number is how we identify the atom. Remember that for each atom or element you find in the periodic table, its atomic number is unique to it. So we first need to find the number of protons, because remember the atomic number for Z is equal to the number of protons. And so in this case, it's 14 protons, right? So I find 14. Now I need to find the element that has an atomic number, which is that number on top in this periodic table. It's basically the number that's not a decimal on the periodic table. And what you want to do is you want to find 14. So notice how the periodic table, the numbers go from 1 all the way across to 2, then it snakes back over here. Now it's 3, 4, keep going, 5, 6, 7, 8, 9, 10. So just snaking around and we find 14 here. And if I zoom in, the name of that element that has 14 protons, or atomic number 14, is silicon. So silicon, and the symbol is Si, because it has an atomic number of 14. Sorry about that. There we go. All right, I'm going to zoom out. I think I need to zoom out here. Okay, so these are the notes that we've captured for the examples. We're now going to do 2 more sets, and the next 2 sets are really just going to be sort of a drill type of thing. So first one is asking us to calculate the charge, and we have to give them the number of protons, neutrons, and electrons. So remember, for charge, you only want to focus on protons and electrons, since they're the only ones that have charges. And so in this case, we have We can do number of protons minus number of electrons, which would be 38 minus 36, and that will give us a positive 2. Remember, for charges, you want to put the sign. So that's positive 2. Or we, of course, could do it using mental math. We see we have 2 more protons than electrons, so it would have a positive 2 charge. All right, next one is the atomic number. So the atomic number is the number of protons. We have 38 of them, so that's easy. So number P, right? So then that'll be just 38. I'm just going to box my final answers. And then finally for the mass number. So remember, for the mass number, this one you only focus on P. For the mass number, you want to focus on the subatomic particles that have a mass. Protons and neutrons are the ones that do. So protons and neutrons, what you focus on. Oops, sorry, I put it in the wrong spot. Should be up there, protons and neutrons. So the mass number is going to equal to the number of protons plus the number of neutrons. And I've got 38 protons and I've got 45 neutrons, okay? So that would be 13, right? And then carry the 1, so 83. And I forgot to put it up here as well. I want to make sure I put down my in terms of mass number, if you're just describing the mass number, you can just write 83, but I oftentimes like to write AMU to remind me that this is describing the mass of the atom. So I'm going to write 83 AMU here, and I'm going to go up and do that as well up here for that mass number, 2070 AMU. And remember, AMU stands for atomic mass unit. It's just a unit of mass, like grams. All right, the last part says to identify the atom. So we're going to go ahead and identify the atom. And remember, to identify the atom, which one of these do we use? Is it the charge, atomic number, or the mass number? Great, it is the atomic number. So we just need to use the periodic table. Oops, spelled that wrong. Periodic table. So we need to use the periodic table. And what we do is we look at the atomic number, which is 38, right? It's the number of protons, and we see if we can find that in the periodic table. So remember, we're just following the numbers around. So if that's 36, 38 must be back over here. And I'm going to zoom in. And it's strontium. Okay, so strontium it is. SR is the symbol. So all right, so strontium is the element that has an atomic number of 38, or 38 protons. Last but not least, so in this last example, we're looking again for the charge. And so if we're looking for charge, we look at protons and electrons. And we can calculate it by subtracting those two. So we have 18 protons, and we have 18 electrons, so 18 minus 18. That means that the charge is 0. The number of protons, number of electrons cancel each other out, so we would say that this is neutral. It's a neutral charge. Okay, next is the atomic number. What do we focus on here? Just the protons. So for atomic number, it's just the number of protons, so that's going to be 18. That's simple. All right, the mass number is the number of protons plus neutrons, right? Because those are the only things that have a mass, protons and neutrons. And so the mass number here would be 18 plus 21, okay? So then that will give us a mass number of 39 AMU. And then the last step is to identify the atom, okay? So if we're identifying the atom, which of these three would help us identify the atom? That's right, it's the atomic number. So I need to use my, I'll spell it right this time, periodic table. Okay, and I go to my periodic table, I'm looking for atomic number of 18. And so I'm screwing around, there, oh, there it is. This is argon. cute little poem for you. My days are boron when you are gone. All right, anyway, so that is argon. And the symbol for that was AR. And once again, oops, let me zoom out. I'm messing up here, you can't see that. So argon, symbol AR. And once again, I got that from the atomic number, which, as you can see, the atomic number of argon is 18. Okay, so that is it for this video. Have a call today.